Um, you got the recording working, well done. What I'm also just wanting to highlight here is the South African Robotics, Ocean Technology and Innovation Center, which was a spin-off of some of the sort of R&D developments we've been doing. And, you know, we realized that there's a really nice collaboration between scientists and engineers here. And so that's really what that center is about. And there's been also a lot of development, HCD development in that space. So we've been training a lot of technicians and engineers. I think they take on board 4 young engineers a year. Okay. Sorry, I don't know why I'm having delayed. There we go. So I just wanted to quickly touch on some research highlights. So we've been doing these deployments since 2012 in the Southern Ocean. We have approximately 7 what we call seasonal cycle experiments. The top panel is just showing you some really high frequency variability of FCO2, so the fluxes of carbon. And you can see, so this is over a 3-month period, and you can see the sorts of scales of variability that you're observing. And in this particular paper, which was led by Pedro, he shows that, you know, you really need to sample at a high frequency temporal resolution to avoid any sorts of uncertainties in the mean. And that was done, this was from a study in the subantarctic zone, and more recently we had a study in the upwelling polar zone. And that particular study looks at how wind-driven variability, how wind drives lateral and vertical variability, but in particular when you have very, very strong storms. So this top panel is, you can think of it as wind stress. Oops, sorry. This middle panel is ocean mixing measured by one of our buoyancy gliders. And then the bottom panel is the flux of carbon. And you see when you get these really deep mixing events, which are short-lived, you have these outgassing periods. And what we noted in this over this period is that these 2 outgassing events dominated the mean CO2 flux. So we really need to try and observe at these sort of temporal scales. Okay, so I mean, I think we're all on board with this, so maybe the slide is redundant, but you know, surface vehicles are extremely good at measuring at these sorts of high frequency scales of variability. And so coordinating will help us to sort of broaden and get a better idea of these sort of emerging insights on the synoptic timescales. And I just wanted to give a shout out to Like's work. He's been doing synthetic observational experiments using different ship tracks and different, you know, sail drone tracks and whatnot, and has shown that really the addition of ASVs is important for reducing biases in the seasonal cycle of CO2 in the Southern Ocean. Yeah, so ultimately, I think that you know, coordinating efforts, particularly in the Southern Ocean, but of course in the global ocean, is really important for reducing uncertainties in our observations. And that's it. Thanks very much.
Fantastic. Great. Thank you so much. Any questions for Sarah? And maybe while we're asking questions, Seb, you can be pulling up your presentation.
I have a question for Sarah.
Yeah, Ruth, go ahead.
What type of changes did you have to make to the wave glider to have so that it could suit the winter conditions?
Yeah, so it's in development. So the first thing we did was extended the hull so that we could get more solar panels on it. And then we've been developing some other, like a hydro generator and whatnot to, and yeah, those 2 things have been the main,
Okay, great. Okay, Seb, you're up here. Welcome from out in the open ocean there. And hopefully the rocking and rolling. I know that you're in a storm right now and kind of aren't really fully operational, but here you are. So take it away.
Thanks, Megan. I hope you can hear me all right and you can see my screen, I guess. Yeah, great. Yeah, so hello from the Roger Revel. We're down here in the Cape Basin, or the Cape Cauldron, and it's definitely a cauldron out there today. We've hit some big storm and we're hunkering down. So if I'm swaying, it's not from alcohol, but from the vessel, I promise you. It's very nice to give this talk from the ship, and it's amazing that the Zoom call works. If I drop out for some reason, then one of our ECOP theme team leads, Marcel Duplessis, will take over my presentation. And he's a theme team lead of the Fair Data Practices theme team of OASIS. And he's actually here, pictured in third person here in the row. And I'm just introducing some of the Polar Gliders team members from Sweden, from Gothenburg, who are using a bunch of USVs. And in particular, Sarah's just spoken about the Wave Glider, which I won't mention today because she's presented it. But we're out here having deployed one of her instruments in this project too. And this photo on the bottom right was from yesterday when we rendezvoused with the Wave Glider after several weeks of it sampling to check that it was still doing okay. So we really use these USVs and gliders. So I had to include one of an underwater glider here, even though it's not a USV, because how important it is to give us information of both the ocean interior and the surface from the USVs all at the same time. And we really use this to try and understand submesoscale flows in the mixed layer and their impacts on air-sea fluxes of heat and also through Sarah's work, carbon. So as Sarah was alluding to, there's big data gaps across the global ocean. She mentioned SOCAT. And here I just wanted to mention, in general, our gap in observations we have from surface observations, which is the bottom panel here over the Southern Ocean. I'm really mostly Southern Ocean focused, so I'm biased in my slides to that region of the global ocean. But the top panel here is sort of winter observations of the actual ocean temperature or salinity or whatever it might be. And this is dominated by the Argo program and more recently in the Southern Ocean, the SOCOM float program. And this shows 10 years of observations. And then what's striking is that if you had to think of what observations we have of the surface ocean and the lower marine boundary layer is the bottom panel, they're starkly different. And the gaps are even bigger, and the seasonal gaps are even bigger than that. And so we're highly reliant until recently only on ships, some buoys, and then 2 moorings in the whole Southern Ocean. One is the SOFS mooring, South Australia, and the other one, the OOI mooring in the Pacific. And so it's really, really a critical gap that we try and find ways to plug these holes of our knowledge around the surface ocean and air sea fluxes from various platforms. And of course, the USVs have a critical role to play to try and fill these gaps in both space and seasons. Today, I'm really focusing on one particular USV because we've had presentations a little bit about sail drones and then about wave gliders. And there's another one, and this is the Sailboy. And I think David, the manufacturer, is on the call, so it's very nice to have him here from Bergen in Norway. And this is a video from Offshore Sensing showing what these Sailboys experience. And you might have seen this for other USVs like sail drones or wave gliders plunging through waves. And really the message here is to say that this is the nastiest place to make observations. Toughest conditions, big waves, big storms. Sensors that get battered and platforms that get battered. So this is really difficult to make observations in the lower marine boundary layer. Here is the Sailboy, and it's sort of a platform I wanted to focus on today, really because it is a relatively, in inverted commas here, a relatively cheaper, robust, and long endurance platform that could be used for within a USV network for the global ocean. And here it is on the deck of the icebreaker, the South African icebreaker, the SA Gullis, some years ago. And the bottom plot here is yesterday us deploying our newest sail buoy called Pim Pim. They're all named after Swedish cakes, by the way. But this is Pim Pim being deployed off the Roger Revelle in the Cape Basin just yesterday morning before the storm came in. And this sail buoy's got a CTD in it, an RBR Legato CTD in a bulb on the keel. We've got an ADCP, and then it's got a little MET sensor here, which measures winds pretty well, but nothing else. But what we did add on here very recently is we've integrated for the first time a relative humidity sensor, so that we can try and constrain some of the turbulent heat fluxes better from these USVs, even from a tiny platform like a sail buoy that's measuring, just 1.5 meters above the sea surface. We're trying to see if our measurements of relative humidity are actually something real or just a bunch of sea spray hitting the sensors. So this is going to be a real test for us to see if this works. And I know others in the US, like Tom Farrar in S-mode, and others are also testing this idea of measuring relative humidity accurately. So we'll let you know how that goes in the coming days and weeks. These robust platforms survive against all odds. And this is one of our first sail buoys called Kringla. And it has been through the most incredible adventures. It's had leaks in the middle of the South Atlantic Ocean. And then we've had to sail it back all the way from the ice edge at around 60 degrees south, all the way to Cape Town, and make it hit a beach so that we can recover it off the beach some days later. And just a few months ago, this was one of our sail buoys that completely iced up at around 65 degrees south near Mode Rise. And when the Polarstern got there, it just was a chunk of ice block around the Airmar here, which is a nice popsicle, and a big block of ice on the wings as well on these sails. And the bottom picture here is actually a piece of its wing chopped off after it was recovered on the Polarstern, patched up and redeployed, and carried on going for a couple of months more. And then we recovered it on another ship, about 4 months after that. So these things are really robust and may survive and have endurance for long periods of time. And here's just a snapshot of one of our missions of the sail buoy. This was several years ago when we deployed just off the sea ice edge in the Antarctic marginal ice zone. And like Sarah had showed, is the value of pairing these surface platforms with gliders. And so this was paired with sea gliders, and it continued sampling for several months in this corridor that you see here, this north-south corridor. And did very well given the circumstances of the strong Southern Ocean winds and conditions, and collected some wonderful high resolution data for us. And this is just a snapshot of the salinity and temperature data. And this really gave us the first view of the very fine scale surface ocean conditions, such as temperature fronts, here are salinity dominated fronts in the Antarctic MIZ, that are really occurring at the sub-mesoscale, hundreds of meters to several kilometers, which was really interesting to note, and shows us how important it is to understand the scales of processes and how they impact air sea fluxes right across the global ocean. And very lastly, here we are in Quiche on the ship. And this is an NSF project led by Lisa Beale and many others. I'm one of the PIs for part of this work, and this kind of cartoon, which is our Quiche logo, kind of summarizes where we are. There's sort of South Africa in the corner, and we're trying to take a slice of the ocean during the cruise and sample this wonderfully dynamic, exciting, extreme EKE and very turbulent conditions with all these wonderful platforms that we have on the ship. We have a wire flyer doing slices through the ocean. We have VMPs. We have about 300 drifters, a sail buoy. We've got 2 sail buoys. We've got Sarah's wave glider. We've got 3 other gliders measuring nitrates, ADCPs, turbulence, pies, and then 2 tall moorings of the Miami group that are lying under the Swart crossover site in the Cape Basin. So we've got 1 week left of this cruise, and it's been a huge learning curve to see all these platforms working in unison to collect this data. This site's very important for air sea fluxes. It's very turbulent, so you have very high EKE. And with that comes very large air sea fluxes. This is the winter air sea flux, where the ocean is really losing huge amounts of heat to the atmosphere as the Agulhas current retroflects and sheds these big Agulhas rings that go into the Atlantic Ocean. And so it's really crucial to understand these air sea fluxes, to understand water mass transformation, really understand the mesoscale to submesoscale interaction and how these impact fluxes. And these have implications, of course, the leakage around South Africa and therefore the AMOC. Here's our gliders and all the platforms together. So we're having a glider USV Palooza in the Cape Basin mosh pit, and we call it a mosh pit because our first set of 100 sort of drifter deployments ended up in this wedged between this Agulhas ring and a cyclone in the Cape Basin here, and they've been going crazy around and around, dodging the very strong currents. And we deployed then a few of the gliders and the sail buoys and the wave glider to sample this mosh pit area. And it's been truly very, very interesting for the oceanography and the air sea fluxes so far with what we've measured. So they've been following each other around, and the USVs are following the gliders. And the wave glider is done exceptionally well because it's very well powered by the waves. And the sail buoys are catching up in the wind-driven circulation against these very strong currents, often 2 to 3 knots at a time. Really tough for piloting. And the ocean's been just remarkably interesting. And here's just an oxygen section from one of the gliders under these USVs. And there's so much structure at all these different scales. And I mean, really, this has been, a lot of this has been done by all these wonderful early career researchers that we have on board. We've got master's students, bachelor students, PhDs from University of Cape Town and from SOCO. And then we've got other PhDs and postdocs from Gothenburg. And then there's a whole bunch of others that are not in this photo, the American team, more South Africans, the Welsh bunch doing the VMP. So it's been fantastic to have all these different career levels and cultures all mixed up on the ship doing this fun science. I'll leave it there.
Fantastic. And so right now there's this storm going on, and is the sail buoys and the wave gliders out there making their measurements? That's exciting.
Yep, they're in the mosh pit and they're all together. So we have 6 different gliders and USVs together. And they're all out there and during the storm, and some of them, 2 gliders are going to be recovered in about a week. The Sea Explorers that don't have much battery, they only can have endurance for about a month. But then we hope the wave glider, the sail buoys, and the other sea glider are going to stay out for several months after that, after the cruise. We hope.
That's exciting. Super exciting. Okay. So any other questions for Seb before we go into the open discussion part?
Hi, Megan.
Yeah.
Yeah, can you hear me?
Yes. Hi, Shengli.
Okay. Yeah, it's great to see all of you. Hi, Seb. I have a question for you. So it's really exciting to hear about the sail buoy, the buoy. It's my first time to hear that. So I was just wondering what kind of parameters.
Oh, we might have just lost Shengli. Do you want to ask your question again?
Yeah.
I can hear her.
Can you hear me?
Yes.
Okay, my internet is very bad here. So for the sail buoy, how many parameters does it measure in the ocean? What kind of parameters does it measure?
Yeah, when we first had our sail buoys, they could only really measure temperature and salinity and some METOBs, some basic wind and air temperature and pressure. And over the years, they've been integrating more and more sensors on their sail buoys. And now we have CTDs, we have METOBs, we have now the relative humidity sensor. We have an ADCP, which gives us velocities up until about 50, 60 meters below the sail buoy. Other sail buoys have wave sensors, the data well wave sensors, EK80s to look at biomass, And I think that's maybe about it. But David is also on the line. Maybe he has other sensors he's integrating on the sailboys. So even though they're quite small, their payloads are getting, bigger and bigger because of, sensors are becoming smaller and their power needs are becoming less. So they can carry quite a lot, but nothing like a sail drone, with all its Christmas tree variety of sensors that the sail drone can have.
Okay, that's great. So one more question: how much it cost to buy a sailboy?
Yeah, they're cheaper than the other, the wave gliders and the sail drones, but they're roughly in the order of $150,000, depending on sort of what payload you're looking for. But in that area.
Okay, just curious. Thank you.
I
I
have
have
a-
a question,
Oh.
Seb. Sorry.
Okay. Okay, Krista has a question about whether we should be recording the open discussion or not. Should we stop the recording so that maybe we can have really frank questions and discussions that aren't recorded?
I don't
Okay,
mind.
so Krista will let us know if the recording is turned off. I'm not. Okay, Ruth, go ahead with your question.
Yeah, it was two questions. Number one, how deep does the CTD go? And number two, what's your interface like? How are you managing so many different pieces of equipment? Do you have one common interface, or are you using lots of different interfaces?
Ruth, I wasn't just checking.
I beg your pardon? What was that?
Was that a question for me?
Yes. Yep. How deep is the CTD?
The CTD is only a surface CTD, so it's just measuring at about 40 centimeters, 50 centimeters below the surface, maybe a bit more than that, but it's not a profiling CTD. The sailboy doesn't have a profiling CTD, and I know that obviously the sail drone and the wave gliders are introducing those capabilities, but this is just surface TNS. We don't have a common interface, and this is a very good question because obviously that's a big challenge, I think, for a USV network or any autonomous fleet that's out there. But right now, we're dealing over 4 different interfaces piloting the different gliders or the different USVs that are out there. And we have to actively coordinate between all of us, like, we're WhatsApping and Slacking all the pilots. Sarah's wave glider, go follow this glider go there, these sailboys go there. And it is a challenge, I think, for the near future, because we do need an integrated interface, or at least some kind of AI that's able to communicate between platforms to do adaptive sampling or optimize their sampling with less need for human intervention. So I think on a technological standpoint, that's a very big point you bring up here as a challenge for the future.
I have a follow-up question for this. It's as a scientist, I think that would be overwhelming to have a 24/7 year. I mean, it's one thing for you to be out there at sea and dedicated for a month doing this, but doing this for year after year, it's a big commitment. And so that's where we kind of bring in these public-private partnerships and the value of private companies. But I'm wondering if there's kind of an in-between way of doing it, like through like SOCO. And so Sarah, I'm wondering if your group pilots or you know, other groups, is that something that you've thought about, or is it's a question for Sarah?
Sorry, hi. Megan, I struggled to hear a lot of what you said because you
Okay.
broke up a bit. But I think what I made out was you were asking about piloting and it being, you know, a huge task to try and pilot multiple platforms, particularly over the years. And you were asking with a SOCO. So through SA Robotic, which is this sort of collaboration that we've formed with another engineering company, private company called C Technology Services. They're like an SME in Cape Town. They manage our piloting. They provide engineering services. They do all of that for us. And that was really to try and take the burden off the scientists. But I'm not entirely sure whether you were suggesting, yeah, I wasn't entirely sure what actually you were asking, but that's how it works at SOCO.
I see. So in fact, do you contract out a lot of your piloting to these other commercial, what you're saying? It seems for doing that. Any other final questions here as we come into the last 2 minutes? Okay. I'm going to turn off my video.
Yeah.
Okay. Shuajin. Shuajin. Chen.
Oh, okay. Yeah. Hi, Sam. I have a question about your Cebu. You have mentioned that you have mounted the ADCP or EK. I'm wondering whether the data transmission is real time, because ADCP or EK provide a lot of data. So are the data transmitting in real time or non-real time? That's my question. Thank you.
The data, most of the data is transmitted real time, but for those users who have ADCPs like us and EK80s, a lot of the high resolution data can be stored on board and we get snippets. In fact, I think we're getting almost all of our ADCP data in real time anyway, but I know that EK80 people probably have to download their data when it comes on board. I think we get like 1 minute ADCP data right now, and we could, when we get it on board again, we'll download maybe a couple of second 2 or 3 hertz data when it comes on board.
Yeah, it is currently not available to transmit the EK data because it's too huge of data. Thank you.
That's right.
Okay. Great. We're kind of at the top of the hour now, and so I want to kind of wrap this up, but I do want to highlight Carlos Barrera's message there in the chat. I'm going to put it in here again. Oops. Let's see, I got a little bit more. But you're seeing some of the chats between Krista and I as well. But the EuroC is having a workshop, and you can contact Andres Siaka at plocan.eu or Carlos Barrera at plocan.eu about this workshop that's happening on the 13th and 14th of April. And our next workshop webinar will be after that on the 20th, and looking forward to seeing people again. Okay, thanks so much to all the speakers and to everyone